This last section, so the last section for today is the R environment for statistical computing. So this isn't going to be so much of how to do stuff. It's basically, I just want you to try doing some of these things with a computer once, because that's really the only way that this is going to be practical. So what is R? This is sort of the programming language that's been adopted by the CF and RM department. So R is a language and environment for statistical computing and graphics. Luckily, statistical computing ends up being very, very similar to scientific computing. So that's mostly just solving things with matrices. So R offers, and this is not an exhaustive list, data handling and storage, a suite of operators for calculations on arrays, and in particular matrices. So this is the bullet point that we will be making the most use of. It's also a complete programming language. So there are some questions you can solve just by, or some problems you're going to be able to solve just by using matrices and vectors. But if you need to do something more general, or if you want to verify that you've gotten the correct solution, you can actually write something just like it was C or any other programming language. And also, a good thing for us is that it's free software. So if you just click on this link, so it's www.r-project.org, you can download a copy. On the university network, it should take you about a minute between clicking this link and having it installed on your computer. And so when you load up R, it's going to look something like this. So this is a picture for Windows. On a Macintosh or on Linux, it's going to look a bit different. But the important thing is there'll always be this one window in the front called the R console. And this little prompt here, I call it a caret. I don't know if that symbol actually has a name. It's just sort of R's way of telling you it's ready to do something, and you need to type a command in. So you type in a command, and you press return, and it's going to do something for you. And I guess I should apologize for those of you taking 461. This will seem a bit redundant. So you can think of R as a calculator. And so the commands are going to look like, well, in my slides, the commands are going to look like this. So this is the little caret that you're going to see in the R command window. And then this is the input that you're going to type in. And then when you hit enter, this isn't actually running R, so I have to hit down arrow. The output will look like this. This is just a sort of placeholder to tell you that this is the first element of a vector. So that answer is not the thing in the square brackets. The answer is the thing that comes after the square brackets. And so when you do this in R, it's just going to look like this. You see the prompt, you type in 1 plus 1, you hit return, and it types out 2. So hopefully that's pretty clear. That's the answer I expected anyways. One sort of useful thing to know right from the very beginning is if you need help with a function, you can use a function called help. So I type the name of a function, open parenthesis. The thing inside the parenthesis is called the argument. And the argument to the help function is just the name of a function that I want help with. So in this case, there's a function called little c. And I want to see the help file for this little c. Then there's also this gate sign or pound symbol or number symbol. I guess it's got a lot of names. And this is what you use in R to comment your code. So this is one line that I could type into the R command prompt. But R is going to see this symbol, and it's just going to ignore everything that comes after it. So I could say I can leave myself messages in. You won't do this so often in the console, but if you're making a script file that you're going to cut and paste in the console, you might want to leave yourself messages for what each line of that script is doing. And so here my message is saying that $C is going to do the same thing as just saying help and then giving it the argument C. So I can do help C, and that'll give me the help page for the C function, or I can do $C, and that'll give me the same thing. So the first thing we're going to want to be able to do is make vectors. So this little c function that I was talking about, this takes values and puts them together into a vector. So this is going to put the values 34, 12, 65, 24, and 15 into a vector in this order. And so the output of that just looks like this. So again, I get this 1 in square brackets. All that's telling me is that this 34, the thing right next to it, is the first element of this vector. I can also use this colon to get sequences of values that differ by 1. So generally, the only way this makes sense is if I say an integer value colon another integer value. So if I do -3 colon 7, that's just going to give me -3, -2, -1, and so on up to 7. If you want a little bit more control, there's a function called SEQ, which stands for sequence. And so I can give it multiple arguments. To find out what all the possible arguments are, you have to look at the help file for the function SEQ. So here what I'm telling it, I want it to start at 0, I want it to go to 1, and I want it to take steps of size 0.05. So when I run this, it prints something like this out. So the first one is 0. Then in steps of 0.05, it goes up to the number 1. And so now you can see it's a little bit more clear what this 1 is here for. So it's telling me that 0.00 is the first element of this vector. Then I have 2, 3, 4, 5, 6, 7, 8, 9. And then 0.45 is the 10th element of this vector. So it's just a little aid so you can kind of figure out about where you are in a vector when it has to be split across multiple lines in the output.
Assuming a row vector there?
So a vector doesn't really have row or column by itself. It's only when you start to talk about matrices that it has a row and column format. And so R actually, I think most of the time, if I have a vector and I need to put it into something with 2 indices, so I need to put it into an equation with a matrix, I think of every vector as a column vector. And if I want it to be a row, I put a little t next to it. And I'll talk about that in next time. Here are actually, well, I'll get to an example that'll hopefully be a little bit more clear about that. So then another useful thing you can do in R is you can save the result from one computation to use in another one. So here I'm going to make a vector that has elements 24, 30, 41, 16, and 8. And then I'm going to store that in a variable called x. And so when I do this, now there's no output, because instead of taking that output and printing it on the screen, R is just going to put that output into the variable x instead. Oops. And so if I want to see what x is, I can now just type x at the command line and hit enter. And now this prints out what's stored in this variable x. So it's the vector that I created in this first command here. So 24, 30, 41, 16, 8. And once I've created a vector, then I can manipulate it. So this is my vector that I created on the previous slide, and I called x. And I use square brackets to get at the individual elements of x. So here, x3 is going to refer to the third element of x. So if I run this on the command line, I just end up getting a 41. Everything in R is treated as a vector. So this 3, even though you think it looks like a scalar, internally R is treating that as a vector of length 1. So I can also subset on vectors, and that's going to probably have the predictable result. So if I give a vector of indices, this is going to refer to the first, second, and fourth elements of the vector x. So that's going to be 24, 30, and 16. And so when I do that on the command line, I get 24, 30, 16. So I can get a subset of the elements out by giving a vector argument to this to the square brackets. And then I can also use this subsetting for assignment. So suppose I have my vector x, and I want to replace the first, second, and fourth elements with -1. Well, this was a subset that took those elements out, so it somehow refers to those places in the vector. I can use my assignment operator, this little arrow symbol, to put a -1 into those places in X. So if I have X currently as holding this, when I run this command, it's going to replace those entries, so the first, second, and fourth entries with a -1. And so now when I look at my value X, I end up with -1, -1, 41, -1, 8. So the first, second, and fourth entries have been replaced by a -1. I can do vector arithmetic. So remember when I talked about adding two vectors, they were added element-wise. So I just sort of made up a new vector x. My vector y is just integer values from 1 to 8. So x has length 8. So I can use x plus y to add those together. And so this just ends up being 1 plus 6 is 7, 2 plus 12 is 14, 3 plus 4 is 7, and so on. And plus, minus, multiply, and divide are all implemented this way in R, so they just happen element-wise, and the vectors have to be equal length. And then a lot of the other functions in R also work that way. So for instance, the logarithm, so this is log, log is log with base e, not base 10. So R treats this as a natural logarithm. And that's just going to return, so this first element is the natural logarithm of 6. Second element is the logarithm of 12, and so on. And then I can also scale and shift a vector. So if I have a vector of length 1, or I'm going to think of it as a scalar, and I use the star, so multiplication, this is going to be interpreted as 2 times each element of x. And then when I subtract a vector of length 1, that's going to be the same as subtracting a scalar. So I think of this as 2 times each element of x, and then each of those elements minus 3. So if I run this command, I'm going to get 9, and that's just 2 times 6 minus 3. 21 is 2 times 12 minus 3, and so on. And now that's sort of my brief introduction of vectors. And then I can create matrices using a function called matrix. So I'll first start by making a vector x that just has numbers 1 through 16 in it. And then I'm going to use the matrix function to turn that vector x into a 4 by 4 matrix. So the first number here is the number of rows, and the second number is the number of columns. Oops. And that's just going to give me a matrix that looks like this. So it's 4 by 4. And it's put the vector into the column. So it's put the first 4 elements in the first column, the second 4 elements in the second column, third 4 in third, and fourth 4 in fourth. If you want it instead to go by row, you can give the matrix function this optional by row equals true argument. And now instead of filling this in column by column, it's going to fill it in row by row. So I get 1, 2, 3, 4 in the first row, 5, 6, 7, 8 in the second row, and so on. So for manipulating matrices, suppose I have a 3 by 3 matrix. So I'm kind of combining more and more commands into one line here. So here I'm creating a vector that has numbers 1 through 9 in it, and then I'm using the matrix function to turn that into a 3 by 3 matrix. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9. To get at the individual elements, I can use square brackets now, but because I have a matrix that's got a number of rows and a number of columns, I have to use 2 arguments with my square brackets. And so if I say A2, 3, that's going to be second row, third column, and so I get an 8. And that's what I see here. You can also select multiple rows and multiple columns by giving vector arguments here. So this will take the first 2 rows of A and the second 2 columns of A. And so we end up with, so remember the first row first two row, or the first column was 1, 2, 3, but I haven't selected that, so that dropped off over here. Then the second column was 4, 5, 6, and the third column was 7, 8, 9, but I've only asked for the first two rows here, so I get 4, 5, and 7, 8. And then I can also leave an argument empty to mean I want everything. So instead of being forced, if I wanted all three columns here, instead of being forced to write 1:3, I can just write comma and leave that space blank. And R is going to interpret that as select the first two rows and all of the columns. So I end up with the first two rows of my matrix A. And then I can also use the T function to take the transpose of a matrix. So this is something I'll talk about on Wednesday. But this is just the transpose of a matrix is just a matrix whose rows are the columns of the argument. So the rows of A transpose are just going to be the columns of A. And so that takes the first column of A, which was 1, 2, 3, and makes that the first row of A transpose, and so on. So I have to start this section out with a warning. So R always considers a single star to be component-wise multiplication. So suppose x and y are vectors of n components. So here I chose n equals 4. And I say x is 4, 3, 2, 1, and y is 1, 2, 3, 4. And you might think, because x and y are vectors, that if I multiply them together, what I'd be getting is the dot product. But actually what I get is just the element-wise product. So this is 4 times 1, 2 times 3, 3 times 2, and 1 times 4. So I think I might have screwed that up, but you get the idea, I hope. Yeah. So for the dot product, you have to use this symbol here. So it's percent star percent. And that means to do multiplication using sort of the multiplication rule appropriate for the type. And so since x is a vector and y is a vector, this will then be interpreted as x dot y. And so if I do that, I end up getting 20. And the dot product would actually have just been the sum of these elements here. So if I look at that, 4 and 6 and 6 and 4 are both 10, and 10 and 10 are 20. And you can do a little sanity check just by using the sum function to sum those up for you. And that also is going to give me 20. So now we can think about matrix vector and matrix matrix multiplication. So I sort of theoretically have a vector of n components. And let's let A be an n by n matrix and B an n by p matrix. And so I'm choosing a different letter here because I want it to actually be a different number. So the operation x percent star percent A, this is going to treat x as a row vector. So this is sort of your question, Bill. So it recognizes that if I want to pre-multiply by A, because of my multiplication rules, whatever is over here has to have the same number of columns as A has rows. So if this is a vector, if x is a vector, it's going to make that into something with several columns. And then if that has the right size, it will then go ahead and do this multiplication. And then if I put x on the right side, now x has to be a column vector. So R is going to treat this as a column vector. And it is possible with the matrix function, if you tell it to create a matrix with one row or one column, you can force x to be a row vector or a column vector. And in that case, if x were forced to be a column vector, so it's actually a matrix with just one column, then when I do this, it's not going to work. The operation A percent star percent B, that's just going to give me the matrix product AB. And that'll work because the number of columns of A is equal to the number of rows of B. On the other hand, if I try to do B times A, so B matrix product A, that's going to give an error because the dimensions of A and B B and A are not conformable for multiplication. So I can't do B times A because P is not equal to N. And then one last thing. So recall I had this system so this is the system from the first quiz. And we found that the answer was, oh, sorry, not the first quiz, from the first set of slides today. We found the answer was -1, 2, 2. And I had solved that by elimination. And so we can also do this in R, just using the solve function. So this is actually a very common problem that you want to be able to solve. So there's a function built in that's going to do this for you. So I can first make my coefficient matrix A, and I did it here just by typing it in. Then I make a vector B that just has 2, 8, 10 in it. And then I just call the solve function. The syntax is the coefficient matrix, and then the right-hand side vector. And that just prints out the answer, -1, 2, 2.